When building an industrial control panel fed from 480 volts 3-phase and needing to run existing 120 volts single-phase equipment in addition to the 3-phase equipment, and requiring approximately 90 amps of 120 volts single-phase power, equating to a 15 kilovolt ampere transformer, finding the appropriate circuit breaker for the secondary and managing the distribution to 14 circuits each with its own breaker within an M12 enclosure requires careful consideration. Standard circuit breaker ratings for 120 volt single-phase applications do not include 150 amps. A 2-pole circuit breaker with a rating of 250 amps will be needed. It is recommended to split the 150 amp load into two 70 amp chunks. This ensures that each circuit has sufficient capacity and prevents overloading. The M12 enclosure must have sufficient space to accommodate firstly the 150 amp single-pole transformer on both the primary and secondary sides, secondly a 250 amp 2-pole circuit breaker, thirdly 14 circuit breakers rated at least 70 amps each, and fourthly all necessary wiring and terminations. The recommended configuration involves several steps. 1. Install a 150 amp single-pole transformer to step down the 480 volts 3-phase power to 120 volts single-phase. 2. Connect the secondary of the transformer to a 250 amp 2-pole circuit breaker. 3. Split the 250 amp circuit into two 70 amp branches. 4. Install 14 circuit breakers, each rated for 70 amps or higher, to protect the individual branch circuits. 5. Mount all components within the M12 enclosure and ensure proper wiring and terminations. When selecting a circuit breaker, remember standard ratings for 120 volts single-phase don't typically include 150 amps. Therefore, a 2-pole 250 amp breaker is necessary. Splitting the 150 amp load into two 70 amp sections is highly advisable. This ensures adequate capacity for each circuit and avoids potential overloads. Ensure an M12 enclosure provides enough space for the transformer handling both primary and secondary voltages, the 250 amp 2-pole breaker, the 14 individual circuit breakers rated for at least 70 amps each, plus all connecting wires and their terminations. Begin by installing the 150 amp single-pole transformer to convert the 480 volts 3-phase to 120 volt single-phase. Then, connect the transformer's secondary side to the 250 amp 2-pole circuit breaker. From there, divide the 250 amp circuit into two separate 70 amp branches. Finally, install the 14 individual circuit breakers, rating each at 70 amps or higher, to safeguard each branch circuit. Make sure all components are securely mounted inside the M12 enclosure with correct wiring practices. Consider the transformer's role. It converts the higher voltage 3-phase power to low voltage single-phase power suitable for the 120 volt circuits. The 250 amps 2-pole breaker acts as the main disconnect and overcurrent protection for the entire 120 volt system. Splitting into 70 amp branches allows for a more balanced load and better protection for the individual circuits. Each of the 14 circuit breakers provides individual overcurrent protection for its respective circuit. The M12 enclosure protects the components from dust, dirt, and dripping non-corrosive liquids. Important considerations also need to be made. The selection and installation must comply with all relevant electrical codes and safety standards. Consult with qualified professionals such as electricians or engineers who can provide guidance specific to the application. Regarding the transformer, ensure it is properly sized for the load and has appropriate voltage and current ratings. Verify the transformer's impedance to calculate available fault current and ensure proper coordination with the circuit breakers. Concerning circuit breakers, choose breakers with appropriate interrupting ratings for the available fault current at their location. Consider using supplementary protectors or fuses for additional protection of sensitive equipment. For wiring, use conductors of appropriate size and insulation type for the voltage, current, and environmental conditions. Follow proper wiring practices for termination and labeling. With enclosures, ensure it is properly grounded and bonded to comply with electrical codes. Consider using a larger enclosure if necessary to provide adequate space for wiring and cooling. Remember that the specific circuit breaker ratings and enclosure size may vary slightly depending on the manufacturer and application requirements. Consulting with a qualified electrician or engineer is important to ensure compliance with electrical codes and safety standards.